When it comes to system design, do you know what load balancer algorithm you should use while deploying your application? Do you even know that there are multiple kind of load balancers which we need to know before the application deployment so that these all components can work together in the optimal way? If no, then this video is for you. In this part, we are going to learn the load balancer in a completely different level, and after it you will be able to understand that okay, in this application load balancer must be used here and it should be used here. Okay, so without any delay, let's see what we are going to learn in this part. And in the last section, you will find the system design interview questions. If you are able to answer them, then definitely you can skip this video. But if you are not, then I will recommend you to watch this video completely till the end. So first, if you want, you can go directly to the last part, try to answer the questions, and if not, then you can start this video from the beginning. Okay, so let's start. So in this part, first of all, we are going to understand the single server meltdown. Why we need the load balancer, how this load balancer is required by the complete application, by all of the application which we are using nowadays. It is a particular question which we are going to understand here. Then we are going to see the OSI model. This OSI model is not just for the textbook. This OSI model is used in all the application, and here we will see that how this OSI model can help us to understand that which component come at which place while deploying the application or while developing the application. Then we are going to understand this L7, L4. Again, this L7 and L4 is from the OSI model. And first we will understand the OSI model, these two steps, and then we are going to talk about this public L7 and internal L4 for load balancing, because this load balancing is used for two purposes, not only for one. I will tell you that. After it, we are going to understand the core benefit. When we know all the drawbacks, why we are using this, then it is easy for us to understand the core benefits. We should go for the core benefit and the theory part at the end so that we can understand that, okay, why we are telling this. After it, we are going to discuss about the algorithms, that what are the algorithms which are present and which algorithm can be used for which kind of application. These algorithms are the load balancer algorithms. Then there is a one algorithm called as consistent hashing. Still, that will comes in the part of routing algorithm that we will discuss in detail. But this particular part is something which is doing the solution for some other algorithm. Don't worry, we will discuss a lot about it when we come here. Then we are going to understand that this load balancer is not just only for hardware. There are software load balancers too, hardware load balancers too, so that we can understand that okay, which one should come at which phase. In the end, this top 5 system design interview questions, and I hope that after covering these all 7, not only these 5, any 5 question or any other question which you get over the internet, you will be able to answer. And if not, I'm here, you can ask me at any time. Okay, so here, first we will talk about the problem statement, that how these things worked in a way that we need the load balancer. So first of all, here we have the worker one. This worker one is nothing but the web server. And in this web server, your application is running. So currently, your web application is completely new and not known to many people. Only your friends or colleague or some business clients are using that particular application. So at the part of development, you developed it over a single server, and then you tried and tested all the things, and you thought that okay, this single server is enough to handle 10 to 100 customers, and you deployed it on a single server. So currently on the public internet, all the server will try to access your application, and they will be able to access it, and it will work fine. And in the same machine, you have configured your domain name. That domain name is the one which is used by the customers, and those customers will connect to your web application by the domain name. So all the things you have set inside the etc host and all the things you have configured, like the domain and the security wall, the firewall, everything is on the one server. Okay, so right now it's good. Now let's come to the part. Suddenly you have provided some feature which is not available to the internet, of sorry, not available by the other application. So there is a sudden increase of users for your application, and there are suddenly thousands users are there which are trying to access your application. You didn't imagine that these many customers will come and try to access your application. You have designed and you have set up your web server in a way so that it can handle 10 to 100 customers, but currently there are 1000. And when the 1000 customers trying to access your application or trying to use the features of your application, it will heat up the server. It will create, it will ask for so much resources which might not be available for your web application or for your web server. And in this way, your server can go down. So what you thought that, okay, so what you thought that, okay, I think that I'm gonna need few more servers. Okay, so what you did, you have added four servers right now. So one was the earlier one, and two, three, four are the completely new web servers. And all the web servers, you have initiated all the things, but there is one catch that only in one machine you can provide the DNS configuration, this domain name configuration, not in two, three, and four without any specific software or hardware. So still, over the internet, even in your setup, you have four worker nodes where your web application is running, but still for the internet, only worker one is there to get all the requests from the internet user. So still there are thousands of users which are trying to access your application, and still they are going to the one system. In place of distributing the load, in place of going different servers, they are still going to worker one. So we didn't resolve the condition even after adding the worker nodes, even after adding the web servers. So currently, in the same way, it will go to the worker one, and again, it will ask for tremendous resources, and for this, worker one is not ready. Okay, so now what's the solution? So for the solution, we need to understand that this OSI model is not just for the textbook. It is something for the implementation. So when you develop your application, this application layer, this L7, we can start from L1, L2, L3, L4 to the L7. This L7 layer is something which directly interact with your user, or all the users which are available over the internet, they will go and directly connect with the L7 layer of your application. It means there is something you need before the L7 so that this particular traffic will go to the application layer of all the web servers which you have configured to serve that application. So earlier we had that these worker 1, worker 2, worker 3, worker 4, they all are running the web application which I designed. And on top of the L7 layer of all the nodes, I need something which can distribute the load between all. Okay, so one thing I understood that there is this L7. There is the importance of L4 too, but that we will come later. Again, we will come to this slide and we will understand that why we need the L4 too. Okay, so what we will do, okay, so we have this load balancer right now. It is a hidden part. And this this L7 load balancer is something which will come between the worker nodes and the customers over the internet. And this is the one which will route the traffic to worker 1, worker 2, worker 3, worker 4. It will distribute the traffic. So this load balancer is something which we need if we have increased number of customers, or even if there are less customers, still we should use the load balancer, because we don't know that at what time how much load can come from the internet. Okay, so after coming to this web servers, there are few more things that your web application is running on a web server and your DB is running on some database server. These two are totally different things. A database server and a web server. Web server is something which you use to host your application, and this DB server is something where you do the transaction of data, like storing the data or storing the user progress, storing the user transactions, everything. You store it at the database server. That database server cannot be used at the L7 because it have the sensitive data. So it means it will come after the web application, or sorry, after the web server. So if we go sequentially, the first thing which will come is the user, which are available on the left side of the public internet. And on the right side, the first thing which will come is the L7 load balancer. This L7 load balancer will connect the user to the web servers which are hosting your web application. Then we need a L4 load balancer. This L4 load balancer will come between the web servers and the database server. After getting the traffic from the web servers, this internal DB load balancer will reroute the traffic to the available DB servers. But why we need this L4 load balancer, this DB load balancer? It might be possible that at some stage you are going to host a web application which will serve the millions of customers. When you are talking about millions of customers, it means you are going to take hundreds and thousands of web servers which are going to serve the millions of customers. And when we are going to use the thousands of web servers, it is not required that you need thousands of DB servers, because it might be possible that they all are using the same data. So you need fewer DB servers, and for those DB servers to be connected with all the thousands of web servers, we again need a data distribution. So that data distribution will be done by the load balancer again, but this time it is the L4, not the L7. L7 is something which comes between the internet and the web servers, and this L4 comes between the web application and DB servers. Okay, so we understood this part, that okay, right now the traffic is coming to the worker nodes by the load balancer, and the worker is requesting some data or sending some data after the process to the DB server through the load balancer. So it is the part of L4. So now we understood this L4 and L7 analogy and why we use it. Okay. So now let's come to the features that what we have covered. The first thing we did is scalability. So we increased the web server from 1 to 4, or it might be to the 1,000. So because of this load balancer, we were able to increase, or we were able to scale our web server so that it can handle the traffic. So it is the one very good reason that why we need to use load balancer. Then the availability, still the same thing, as the one server can heat up or it can get blocked by the incoming request. So with the load balancer and the available web servers, it will provide the availability to all the users who are going to use your application. Then it comes to the security. This load balancer is something which comes between the web servers where application is hosted and the user. So it means it provide a isolation of the traffic, because you can set some routing table that okay, if the traffic is coming with some kind of SQL injection, you can stop it there. There is no need to send that traffic to the web servers, because if you directly add that web server to the customer facing, they can send the viruses, or they can send some kind of commands which you are not prepared for, and in that way they can hack to your server, which you do not need. So you need something which can isolate these all things, and for that load balancer is the best option. So we understood that this scalability, availability, and security is the main reason we are using the load balancer, and this load balancer is used in all the application which you use over the internet. You can name any application, and that application is using the load balancer. Okay. So now let's come to the part of load balancing algorithm. Still, we didn't talk about that what load balancer we should use. That I will tell you. But first, let's understand the algorithms. So the first one is round robin. What is this round robin? So let's say you have some application which is serving the static data. What I mean by the static data, that user is coming and they are downloading some files, or they are just reading the articles. These are things are called as static data. So it doesn't matter that the user is going to server 1, server 2, or server 3. They all are hosting the same kind of data and they can go anywhere. So it means if you have, let's suppose, three servers placed at your hosting hosting servers, like you have three web servers which are present at the database or some data center, sorry, yeah, this data center is holding your three servers, and these three servers is hosting your web application. Then user can go to any web server. So with the round robin approach, you can just set the load balancer in a way that, okay, request 1 is coming, then go to A, request 2 is coming, go to B, request C is coming, request 3 is coming, then go to C, and so on. So every time when a request will come, it will go 111 to each server. Okay, so in this way, it will distribute the load evenly. Now let's come to the weighted round robin. Why we need the weighted round robin? Let's say at the initial stage, you have deployed your application with a server of large configuration, but you found that, okay, there is only few resources I need more to serve my purpose. So on that basis, you spin one another web server with less resources. Let's say resource that server name is B, and the server with the huge resources, that server name is A. The server A has around 20 CPU and server B has around 5 CPU. And what you want right now is that, okay, I have the server A which have the most of the resources. Server B is also serving the same application, but it do not have that kind of resources. So whenever a traffic will come, I will try to put that load to server A and the least load to server B. So in this way, this weighted round robin is used when you have a configuration of server where one server have most of the resources and other server have less resources. Okay, so this is one another tactical approach to configure your load balancer. Now let's come to the least connection. Okay, why we need the least connection? The load balancer monitors the number of active open connection. It chooses the server that is less busy at the exact moment. So let's say you are using the WhatsApp server. Uh, sorry, not WhatsApp server. You are using the WhatsApp, and in the backend there is one server which is providing all the details of texting, and there is another server which is providing all the media related things. And to server A, there are 10 consumers are already using the server A, and there is only one user which is using the server B. So in that case, let's say there is a one more connection is coming, and they want to start with some transaction of data. So what this particular least connection will do, it will check that, okay, this server A has 10 connection and this server B has one connection. So I will send the traffic to server B. In this way, the least connection, the least numbers wherever are present inside the web servers of the connections, I will send the traffic there. It is that good. It is that much intelligent. It will monitor all the metrics, and then it will start to send the traffic to the web servers where the connections are present. Okay, so it is the least connection. Coming to the IP hash, it is the one method which you seeing on daily basis. And how? Because if you have ever used the Netflix, you will you must have seen that whenever you are watching some movie or some drama, wherever you have left it, again after some time when you will come and you will log into your Netflix account or any other OTT platform, you will see that, okay, this particular progress is still there at the point till I watch, and from now I can watch from this point to the end. It will not let me to repeat the complete video again. So it is using the IP hash. What this IP hash will do, this IP hash will use some formula. what it will use the client IP. It will do some mathematical calculation that you can see the hash of client IP percentile n of servers, number of servers. So let's say Netflix is using 1000 servers and I have the IP of 1.2.3.4. Then what it will do, it will create the hash of my IP, then it will do the modulo of that IP to the 1000 server and it will get some values. After getting that value, it will assign me to that server based on that value. Let's say IP123 map has a hash 450 and 450 percentile 3 server equals to 0. It means every server will have some values, and whatever the output I will get from this mathematical equation, I will be assigned to that server. So the next time when I will come, based on this calculation, it will go there, it will assign me to that server, and from that server I can still see the progress which is saved there. I do not need to go to the DB to fetch all the things again one by one. Everything will be cached there, and this and because of this IP hash method, the cached server, the cache server can help me to do the uh, watch or stream from the same point where I have left. It might be possible that you are getting confused. There is no need to be getting confused. If you have any question, please let me know. Okay. Now comes to the consistent hashing. In consistent hashing, first we need to understand there was one algorithm which was called as modulo n. And there was some drawback in that modulo n, which was covered or which was solved in the consistent hashing. So, what was the modulo n and what error it created, and how this consistent hashing resolved it? So, for that, what I will do some pen work here. And for that, let me just open the pen. Okay, so here I have the pen. And first, let me tell you what this modulo n algorithm was. So let's assume there is there are multiple user and you have the web server called server A, server B, and server C. And there is the load balancer which is present between the user and the web servers which are hosting my web application. So what this modulo n did is there was this formula which was the session ID percentile by the number of servers which are hosting my application. So in this scenario, I had three servers and I have some session ID for the user. So every time when that particular user will come with that session ID, it will be calculated with this kind of formula, and after it, it will send the traffic either to server A, server B, or server C. Whatever the value we will get from here, let's say session ID something some after some calculation it will come as 450, and for the modulo of number of servers 3 it will provide me 0. 0 means server A. So every time for this particular session ID which is around 450, let's say we are just taking the random value here, and in this way it will go directly to the server A. But let's say there is something happened at server A and it got crashed. So currently what I have is I have only these two servers. So for the same formula, for the same session ID, it will calculate the session ID percentile 2. And from now it will get some different value. Not only for that particular session ID, all the sessions ID which are coming to this particular method or to this particular load balancer where this calculation is happening, they all will get reshuffled to another server. And in that case, this caching will get disturbed because you are saving some progress of that particular user in that server. And right now, because that one server is not available, the consumers of server A, not only of server A, server B and server C will also gets affected. And it was a big issue because you do not want to lose any progress if you are doing something useful and not useful. For any case, user is something who is doing their work, and it should not get lost. So there should be something which can protect me to this particular kind of storm, which can destroy the complete reputation of my web application. So for that, there was this uh, approach, this consistent hashing. How this consistent hashing work? Again, here is my user, here is the load balancer where the complete calculation will happen. And this time these servers are placed in a circle. So it is a circle, and let me divide it into three parts. Currently, I am taking only three parts. So it is my server A, it is my server B, and it is my server C. So when the traffic will come to the load balancer, it will get calculated. It will provide some degree. Again, the session ID will come here. Session ID. Session ID will come here and it will do some calculation at the load balancer, and it will provide the degree, and that degree will let the user fall to this particular area. So this A to B is the part of A, this B to C is the part of B, and the C to A is the part of C. So whatever the request will fall under this section will be served by the server C. Whatever the request falls under this particular circle area will be served by A, and whatever the request falls under this particular part of circle will be served by server B. So in this way, it will be calculated. And how it resolved that issue? It resolved that issue in a way. So let's say, again, this server A got destroyed. Okay. It got destroyed. Something was buggy there, and it is keep destroying the server A. When this particular server A is destroyed, this line will get, okay, let me just where is the eraser? Is it the eraser? Okay, let me just, okay, not, it is not the eraser. Okay, here it is. Fine. So right now this A is not there. Now we have only B and C. So whenever, again, the same session ID will come, and it will go to, it will always provide me some degree, and it will let me fall here. So whatever the request will come in this part of circle, it will go directly to the server B. And whatever the users which are falling under this section, they will still go to server C. So in this way, we have saved the consumers of server B and server C, and somehow only the consumers of server A will get affected. So this is how this consistent hashing helped us to rescue the user's data in the disastrous scenario. So in this way, this load balancer algorithm worked, and based on our application, we use these algorithm to work with our application and for the deployment. Okay, so this part is also clear. Now let's come for the hardware versus software. So this load balancer also comes as hardware, and this load balancer also comes as software. This hardware and software, where do we use it? What software should we use it? What hardware should we use it? It's a part of advanced version. Definitely, I will create a video for it because it is a very detailed video. But for you, there is some uh, name I can provide you for, like the software. Broadly, the NGINX is used everywhere, and for the hardware, this big IP is used. BIG-IP. So this software, NGINX, is mostly used at the layer 7, and this big IP is used mainly at the layer 4. Now we know that we need we need the load balancer at level layer 4 and layer 7. So these are the example of software and hardware. Mostly hardware are used for the database, where we need to connect the web servers to the database servers, and there is latency is the main focus which we need to resolve. So hardwares are mostly used there, and the softwares are the one which are handling the traffic mostly from the internet, which is coming directly to the web servers. But there are still some hardwares which are doing the work like Nginx and better than that. That is also comes into the picture, I will definitely create a video. Let me know in the comment section if you want to know the more details. So after this, this is the part for which we have learned all the things. It is the system design quiz. So let's start with the question one. In a high traffic e-commerce app, why is L7 preferred over the L4 for the public edge? Okay, so for the short answer, L7 can read the path. It can route payments to secured PCI compliant cluster and images to a CDN optimized cluster. L4 is blind to URLs and only see IP port. Okay, so let me explain a bit. In a high traffic e-commerce app, why is L7 preferred over the L4? Because the L7, we can provide the routes, we can provide the routing tables. This L4, when we comes to the DB tables, there is only port and IP. So let's say there are some web servers IP. Sorry, this there are some database servers IP, and in that database server, there is mostly one URL and the port which is open to that communication. So that particular thing is only provided by the for the L4. But for the L7, there are multiple fields which we can configure. And for the high traffic e-commerce app, there are multiple things which we need to handle at a same time. The routing of payments, the routing of orders, the routing of customer products, the routing of customer reviews. So these all things are there and these can be configurable at the L7. What happened to user if you use standard modular hashing and one server dies? So we just understood the what modular hashing is. If n changes, the formula percentile hash percentile n changes for everyone, user will likely to be logged out and cache hit will drop to 0 because their keys now map to wrong servers. This is the one thing which was okay, sorry. This was the one thing which was overcome by the consistent hashing. This modular hashing was the one which was creating the issue when one server got destroyed. How does a load balancer distinguish between a slow server and a dead server? Okay, load balancer use active health check and passive checks. A dead server stop responding, a slow server might respond outside a 2-second timeout window. Both lead to removal from the rotation. Okay, so again, these are the properties of load balancer of doing the health check. So you might feel that these questions are not related to those slides, but still, uh, it we need to understand those slides. Then only we can understand these questions and their answers because we have already leveled up our learning. So in this way, our question will get tougher and tougher. Okay, so you have a global app. Load how do you load balance across USA, India, and UK? Okay, this is done at the DNS level. DNS identify the user location via IP, return the IP address of the load balancer closest to the anycast. We have discussed the anycast earlier, but don't worry. If you are not getting this question and answer, in the next part, when we are going to work on the CDN, I'm going to explain you about the CDN and caching servers, then you will understand this question more better. Okay. Does a load balancer become a single point of failure? Yes, there is only one. In production, we use high availability pair, active passive with a floating IP. Okay, where is this? Floating IP. If the active load balancer dies, the passive load balancer instantly take over the IP address and traffic continues. Okay, I guess these are the questions. Again, I want you to go through all these questions again and again. Try to understand the load balancer. It might be possible that you think that these questions are more advanced, but still these are the questions which are usually asked at the time of interview. And still, if you need some help, I'm definitely here. I will definitely create a video for it. If you have any understanding issue, or if you want that I should provide the advanced lecture on it too. I have the data, I can provide it. All I need is just the support that you want to learn. And in the next part, we are going to understand about the CDNs, we are going to understand about the cache servers, and also we are going to calculate that how many CDN servers are required, how many cache servers are required for our web application if we have billions of users. So these are the things we are going to understand in the next system design course part. And this is it for this video. Uh, Thank you. Thanks for watching. And if you like it, then share it, subscribe it, and let me know in the comments if you have any doubts. Thank you.